So we're going to go over some definitions of key terms. If you just want to read these, you can probably just skip a little bit on the video. Okay, but I'm going to read it for the students who like to listen to it, read it out loud. Okay, so first one is population. So this is the entire set of people being studied. Okay, so for example, every student at MAP4C High School. Okay, and then a sample is just a selection of that population. For example, 50 of the students at MAP4C. So every student is population, and then just like a little subset, maybe 40, 50, 60, all the grade 9s, all the grade 12s, whatever it is, that would be a sample. Okay, mean is also called average, and this is, you find the sum of all the data, so you add them all up, and then you divide it by the number of data. Okay, so Peter earned 3 test marks. If these are his test marks, you add them all up, divide them by 3, because there's 1, 2, 3 data points, and then this here would be his average. Okay, we do that a lot for school. Median. When you rank all your numbers from least to greatest, the median is the middle value. Okay, so when I think of median, I think of the word medium, like right in the middle. So not too big, not too small, not too hot, not too cold. So medium, right in the middle. Okay, so if you have these numbers here, it's 1, 2, 3, 1, 2, 3. 5 is the middle number, 5 is the median. Okay, mode. This is like the most frequently occurring value in the data set. So if this is your data set over here, 5 occurs 3 times. Everything else only occurs once. 3, 4, 6, 7. So 5 would be your mode. Range is just the difference between the highest value and the lowest value. So if these were ordered in smallest to largest, we would do 7 minus 3, and it would be 4. So the range of the data, it's like how many data points or like numbers the data is like falls over. Okay, random sample. So when we talk about random, it actually has to be random. So this is just like a sample generated, and everybody has an equal chance of getting selected. So we're talking like names in a hat, or like a random number generator. I know that I use name generators in class. So everybody has a fair chance, a fair opportunity of being chosen. And then bias. A bias is it's an unwanted influence on the sample. Okay, and it prevents the study from being totally fair, also known as being representative of the population. So Sally's name is put into a hat 3 times. Well, if everybody's name is put into the hat once, and Sally's put into the hat 3 times, that's bias. That's not fair, because Sally obviously has a greater opportunity of getting chosen. Actually find the mean, median, and mode of a data set. So here's the data here. What is the mean? So the mean, you have to take every single value. So we have 5, 6, 6, 7, 8, 9, 9, 9, 10, and 11. And we actually have to like manually put that all into our calculator. And we have to divide it by the number of points. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going to divide that by 10. Okay, and what I get 80 over 10. So I get 8. Okay, so the average is 8. Okay. Median, what we want to do is we want to pick the middle number. So what I do for median is I go like from each side. So 1, 2, 3, and then I go 1, 2, 1, 2, 3. And I'm not quite in the middle yet, so I'm going to go 1 on each side. And I get 8 and 9 in the middle. So what happens is there's no actual middle number. So we just take the average between 8 and 9, add them, divide them by 2. The median would be 8.5. Mode is the number that occurs the most. I think it's 6 occurs twice, and 9 occurs 3 times. So the mode is just 9. Okay, it occurs 3 times. Range is the biggest number minus the smallest number, and we get 6. "16 students in Ms. Cameron's class measured their heights shown below." Okay, so we're going to calculate mean, median, mode, and range of this data set. So I'm not going to actually write out that we're going to add all of these numbers. Okay, but I'm going to do this in my calculator, and I get 2723. And if you count the number of numbers, we get 4, 4, 4, 4, so that's 16. Okay, so I get 170.1875. Okay, so for the median, we actually have to rank these, we have to list them in order. I hope I list them right. Okay, 160. Oh, we have 157 before that. So 157, 160, 164, 163. So 163, 164. We have 165, 167, 168, 165, 167, 168. And you have to actually manually go through it. It's a little tedious. 167 again. And then I just write it in. If I forget it, that's fine. Just don't forget that they're up here. 170, 72, 75. I'm just going to continue. 176, 78, 180, and 182. Oh, 179 here. And what I do is I always check that I wrote the exact amount of numbers. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16. Okay, so we're good. So what the median is the middle number. So if you think about 16, and if you think about half of that, it's 8. So 1, 2, 3, 4, 5, 6, 7, 8. But then if we go in from the other side, 1, 2, 3, 4, 5, 6, 7, 8. So we actually have to average 168 plus 170 divided by 2, and we get 169. Okay, mode is the number that appears the most. So looking through it, 167 duplicates, and it's written twice. And I think that's it. And then range is the highest number minus the lowest number. Don't forget that that 157's up there, and I get 25. Okay, so let's take a look. What percent of the class is shorter than the average? So the average is actually 170.18. So this is where the average would be 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 out of 16 students would be shorter than the average or the mean, which is 56.25%. Okay, the median is 167. Let me use another color. What percent of the class is shorter than the median? So the median we set up here, it's right here, 169. So if we actually draw a line where 169 would be, we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 out of 16 students, which is 50%. So 50% of the class is shorter than 169 centimeters. And then the mode, I'll switch my color again. The mode we have 167. So if we're asking for who's shorter than 167, we're actually not going to include it. We're going to cut it off right below. So 1, 2, 3, 4, 5. 5 out of 16 students are actually shorter than it. So we get 31.25. Okay, and all of these are percentages of the class. Okay, so I have just C and D. We're going to do them at the side so that they would fit on the same page. Jake is taller than 65% of the people in his class. How many students are shorter than he is? Well, if he's taller than 65%, there are 16 students, and let's multiply that by 65%, so 10.4. So he's pretty much taller than like 10 students. So then he's shorter than, we have 16 minus 10. He's shorter than 6. He's taller than 10, shorter than 6. He's taller than 10, he'd technically be shorter than 5, because then he would be right in the middle. Okay, so he would be like the 11th person. And then minus him. Let's say 5. Makes more sense. Okay, what's Jake's actual height? So, as an example, if he's the 11th person, if we come back up here and we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, it's between 10 and 11 because we got 10.4. So let's go between 172 to 175 centimeters. So maybe we can say 173 or 174, but we know that he's between those. Okay, example 4, shoe size. So examine the following bar graph. Okay, so when we're taking a look at this, we always want to look at the title, shoe size in a classroom. And what's graphed here is shoe size, let me go to red. Okay, shoe size versus frequency. Frequency means like how many students, number of students that have that shoe size. Okay, so what does each bar represent, and how many facts are known about each shoe size? So each bar represents, well, we kind of just said the number of students with that size. Okay, and then we're going to fill in this chart below. Okay, size 8 feet, how many people have size 8? So we look, we're going to come over here, 5. And percentage of people, well, if you actually think about it, let's calculate the total. So there are 3 people here, 5 people here, 9, 10, 8, and 2. So if we want to calculate the total, 10, 20, 29. Okay, so 37. Okay, the percentage of people, we would do 5 over 37. And that's 13.5%. Okay, how many people are bigger than size 10? So bigger than size 10 would not include size 10, it would just be more. So that 8 plus 2. So we'd have 10, which is 10 over 37. So if you want to express this as a percentage, 27%. Okay, and I'm just going to point out that there's one more question there. It's going to say 9 or smaller. I'm just going to not scroll down just to keep everything on the page. Okay, when it says 9 or smaller, it includes that size 9. So we have 9, 5, and 3. So that's 17. So we would just divide 17 divided by 37. And we get 46%. Okay, examine the following scatter plot. So we have weights lifted and then like 4 people's squat weight and then deadlift weight, okay, in pounds. So we're going to identify the variables, okay? So let's just call this X and Y. So the X variable is always the independent. So let's just say squat weight in pounds. Okay, and then the Y variables, the dependent variable is always going to go up the side. Okay, and then that's their deadlift weight. In pounds. Okay, so I put 2 more questions. What information is given and how many facts are known about each weightlifter? Okay, so what information is given? So for each name, for each maybe weightlifter, we're given what they squat and what they deadlift. Okay, if athletes should be able to deadlift 10% more than their squat, which athletes meet this expectation? So if we actually go up here, I'm going to write like order pairs. I'm going to write 250, 150. Okay, Shauna's at 250, 275. Alexa's at 150, 300. Okay, and then Vicky's at 175, 250. So if we read this, you should be able to deadlift 10% more than your squat. So what you'd want to do is you want to just like take your squat number. So Alexa's squat number is, and remember that's like the X, right? And we put them in pairs, X comma Y. So you take that first number and then you multiply it by 1.1 and then see what we get. I get 165, okay? And then what we're going to do is we're going to compare it. Okay, 300, well, yes, she's good. Okay, Vicky, her squat's 175, and times that 1.1, because it's 10% more. 192.5. So then compare it to 250, yes. Okay, Shauna's squat is 250. We're going to do 10% more by multiplying by 1.1. It's 275. Okay, compare it. Oh, yes. Bang on. Okay, and then Terry's 250 times 1.1. Again, that's going to be 275. And we're going to compare it. No, she's not able to meet that expectation. All right, line graphs. So we're going to talk about reading this line graph. The following line graph represents the average temperature outside over the course of a year. So if you take a look, like in Canada, at least January, February, March, quite cold. Then you have a peak in those summer months, and then it gets cold again. So fill in the answers to the chart below based on the graph above. And I'm going to keep it clean, okay? So how many months have a temperature above 15 degrees? So if you go here, we're reading temperature, we're reading month. Okay, so temperature, we would want to know how many months does this portion of the graph cover. Okay, so let's go. And it says above, so we're not going to count May because May's not above, but we'll count June, July, August, and September. So June, July, August, September, so 4. Okay, how many months have temperatures below 0 degrees? And of course, this is average, right? So this part of the graph, January, February, March. Let's call April up there. And then December, not November. November would be here. Okay, so again, 4. Okay, which month has the coldest temperature? So if you're looking, we're looking for like the lowest here. So I would say February, and it's about -15 degrees Celsius. And the hottest month would be, it would be this peak here. So let's say August, and it would be about, I want to say 28 degrees Celsius. All right. Oh, just one more. When the temperature is consistently above 10 degrees, and so this is like a real thing in real life, you can plant seeds and they'll grow. So how long is the growing season? So anything above this 10 degrees, and it has to be consistently above 10, this is going to be the growing season. So let's go May, June, July, August, September. October it could still grow. So the growing season, May, June, July, August, September, and October. 1, 2, 3, 4, 5, 6. 6 months. Example 6, histogram. The values below show the height of each member in a class in centimeters. Okay, so what we're going to do this time is we're going to do an interval. We're going to do tally based on these intervals here, and then we're going to calculate the frequency. So let's just go one at a time. 188, 179, 188 goes here, 179 goes here, 159, 192, 159, 192, 195, 161, here, 162, 174, 162, 174 goes here, 166, 180, 165, 174, 164, 156, 164 goes here, and then 156 goes here, and then 180. Okay, so create a histogram, and we're going to properly label this. So let's go height of students. Okay, so then this is going to be the height, and it's going to be measured in centimeters, and then up the side is going to be, I just put FREQ, frequency. Okay, so, from the frequency, if we calculate this at 6, we have 3, 3, and 3, and then that's what we're going to graph, of course, with the ruler. Everything's going to be super neat, and that's it. Okay, there's your histogram. So now we can actually sit back and analyze it. How many people have, this is supposed to be height between 156 and 165. Well, that's right here. So 6 people. And what percentage of the people have a height of this? Well, that's going to be 6 over. And then if you go to the frequency column, if we add 6, 3, 3, and 3, we get 15. So if we divide 6 divided by 15, we get 40%. Okay, so 40% of the people have a height of 156 to 165. And then the last one, how many people have a height of 166 to 185? So if you're actually talking about that, and I'll change the color to green, we're actually talking about 2 intervals now. So 3 plus 3, which is 6 individuals.